glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. One of these mysteries is centered here, in the Grand Canyon in Arizona. Close to 1 billion tons of rock have been carved out of the ground. The canyon left behind could hold all the river water on Earth and still be less than half full. For more than a century, scientists have debated how and when this vast chasm was created. And now, geologists are uncovering fresh evidence into the ever-evolving story of how the Earth was made. The Grand Canyon, one of America's most spectacular natural wonders. A canyon 18 miles across at its widest point, 277 miles long, and more than a mile deep. It is so vast that it can even be seen from space. Although Hell's Canyon in Idaho is almost half a mile deeper, and Australia's Capertee Valley is nearly a mile wider, the Grand Canyon remains the most famous of them all. And it also holds one of geology's greatest mysteries. Just how did the Colorado of the Mississippi form such a large canyon? The answer has eluded scientists for more than a century, because many of the clues they normally rely on have been swept away by the river's water over millions of years, or buried by landslides, or destroyed by volcanoes.
It seems like we should understand perfectly how the Grand Canyon formed. The problem is we've lost a tremendous amount of evidence. It's like a murder mystery where most of the evidence is lost. And so the best we can do is piece together the evidence that we have.
Even so, slowly but surely, this geological icon is giving up its most ancient secrets. The canyon's richly colored layers offer scientists one of the most complete geological records on Earth.
The first concept you have to get your mind around as you're thinking about the Grand Canyon is that the stories told by the rocks are exceedingly old, millions and billions of years.
Karlstrom and his team are setting out on a grueling geology field trip along the Colorado River. It won't be an easy ride, because this 1,450-mile-long river packs a punch. More than 800 million gallons of water can flow down the Colorado every hour. More water every second than the average U.S. household uses in a year. Karlstrom is investigating the ancient history of the land that was here before the Grand Canyon even existed. And for that, he needs to identify its oldest rocks. He is following in the footsteps of pioneer explorer John Wesley Powell. In 1869, he was the first man to successfully ride the Colorado through the entire length of the canyon.
All of us who work in the canyon as scientists admire John Wesley Powell immensely for his pioneer and scientific exploration of the Grand Canyon. Still questions that we work on today.
One of Powell's discoveries was these intimidating black rocks at the very base of the canyon.
Well, we're deep in the Grand Canyon, right by the Colorado River. You can see these spectacular black rocks. Actually, John Wesley Powell called them ugly black rocks, because for him, these hard rocks made bad rapids, and that was harder on his trip. But for those of us who are interested in the early history of Grand Canyon, these rocks are the bonanza.
Powell had no way of dating these rocks, now identified as Vishnu schist. All he could conclude from their appearance was that they had once been molten deep underground. But Karlstrom has an advantage. modern instruments that can accurately date the rocks by measuring radioactive decay. And the first step in figuring out what happened here in the ancient past is to record when these rocks were created.
These rocks are about 1.7 billion years of the age of the Earth. So we have a great story here in the Grand Canyon of the last almost 2 billion years of Earth history.
But Karlstrom needs more information. And these ugly black rocks hold another crucial clue to what this land looked like before the canyon was cut. They can tell him not only when they were formed, but also precisely how deep in the Earth's crust they were made. These tiny stones, embedded throughout the ancient boulders, are literally jewels. Garnets that only form under immense pressure. The sort of pressure that's found when layers are crushed by the weight of millions of tons of rock on top of them.
The silver bullet clue is the garnet.
These garnets are the key to understanding the amount of rock above us.
By analyzing the chemical structure of the garnet, in particular its calcium content, investigators can determine how much weight of rock was crushing down upon it at the moment it was made.
In simple terms, if you analyze the garnet and you see higher calcium content of the garnet, it means you're deeper into a mountain belt, more rocks above you. So we take these garnets back to the laboratory. We cut a very thin section. We put them under an electron microprobe. And the scientific result after this analysis is that we were 6 miles deep beneath the surface of the peaks, which were above us. And that's a long ways.
So, nearly 2 billion years ago, before the canyon evolved, ancient mountains 6 miles above sea level stood here. Towering peaks as high as the modern Himalayas. Over the next 500 million years, these mountains were worn away by the relentless forces of erosion. Over millennia, the freezing and thawing of ice cracked open the rock of the mountain slopes. Wind and water carried the rock debris down towards the oceans, leaving behind with no sign at all of a canyon.
Geologists learn to visualize the way that this place looked in the past. Knowing how to read the texture of the rock, the kind of rock it is, the fossils that are in it, geologists can, it's like a detective story. You can uncover what this place looked like billions of years ago.
This is now desert country, more than 300 miles inland. And yet, these shells, encased in solid rocks, are ocean fossils.
In this one cliff, you can find fossil shells that look like you'd pick up on the seashore today. They die, they fall to the bottom of the seafloor, and they get trapped and die in the mud at the bottom of the ocean at the time that they're being deposited.
Shells like these come from shallow tropical waters, an inland sea that first arrived here 500 million years ago and covered the flat, low-lying plain. But that did not happen just once. Many different layers in the walls of the Grand Canyon tell Karlstrom that over hundreds of millions of years, this land has been submerged by the sea, not just once, but at least 8 times. The last time this part of Arizona was under the sea was around 80 million years ago.
As we go higher in the layers in the Grand Canyon, we have different aged seas which are depositing different kinds of rocks, different environments, different fossils that live at the different times. This chapter of seas coming in and seas going out is itself hundreds of millions of years.
Each sea deposited different types of material that hardened to become solid rock. Some sediment was sand that became buff-colored sandstone. Some was mud that hardened into darker shale, while the calcified remains of marine organisms were crushed into light-colored limestone. And yet, the dominant color that comes from iron, locked within all the rocks. Over millions of years, the iron rusts into a distinctive red hue. For the geology detectives, descending into the Grand Canyon is like traveling back in time. The calcium content inside garnet gemstones reveals that nearly 2 billion years ago, mountains the size of Mount Everest stood where the Grand Canyon is now. Sea fossils exposed in the cliffs show that as late as 500 million years ago, the land was the muddy bottom of an ancient inland sea. The next puzzle for geologists is uncovering which awesome forces transformed that unremarkable flat land into this breathtaking natural wonder of the world. From 1.7 billion years ago to 70 million years ago, the landscape of western Arizona extraordinary changes. Ancient mountains have given way to prehistoric seas, which have withdrawn to reveal a low-lying flat plain stretching as far as the eye can see. The magnificent gorge of the Grand Canyon does not yet exist. But over the next 20 million years, this landscape was to undergo immense changes that would create a unique high plateau and set the scene for the formation of the canyon. Ancient fossils of sea animals tell geologists that this land was once under the waves of an inland ocean. But that leads to yet another mystery. The investigation needs to figure out why these undersea rocks are now high in the air, thousands of feet above sea level.
It's surprising to go up a mile above sea level and you find a clamshell, or what looks like a clamshell. And you say, that's what I see when I go down to the ocean. So why is it here a mile above sea level?
It's clear that this region underwent a type of geological disturbance. Seabed pushed up. Geologists discovered in the 1960s that collisions between separate plates of the Earth's crust could force land up into the air. It happens all over the globe and usually deforms the land into tilted mountain ranges. But this Arizona uplift was unique.
After all the flat layers are deposited at sea level, there was a major uplift event called the Laramide orogeny, which lifted these rocks without tilting them, still flat, lifted them up to high elevation.
Because the land rose straight up, like being in an elevator, it formed a high, smooth plateau. The sea that had been there drained back toward the northeast. But as of yet, there was no Grand Canyon. The Colorado River, the force that cut the canyon from the rock, had yet to arrive.
Geologists from the very early days, from the late 1800s, are quite comfortable with the knowledge that the Colorado River has carved the Grand Canyon.
The high plateau was surrounded by even higher mountain ranges. New rivers began flowing from the mountains out across the plateau. To establish when the Colorado River in particular arrived, because only then could it begin to carve the canyon. Until a few decades ago, some investigators thought this ancient riverbed, called Hindu Canyon, provided the answer. They believed that Hindu Canyon's creation, 50 million years ago, marked the arrival of the Colorado River and the beginnings of the Grand Canyon. But in 1969, the discovery of these pebbles turned everything that geologists thought they knew about the canyon on its head.
Turns out that to explain how the Grand Canyon got there is very much more complex than people thought. So the early geologists thought it was simple, but now we realize there's a lot more to the story, and it's kind of a detective story. You start out with a few clues, and you put the clues together, and then finally you get the satisfaction of saying, well, you know, I figured this out before anybody else did.
Figuring it out before anyone else was just what Young did in 1969, when he was a 24-year-old geology graduate student at Washington University. His professors sent him to investigate Hindu Canyon. But when Young arrived at the dusty riverbed, nothing to do with the Colorado or the Grand Canyon itself. His discovery flew in the face of all the established geological theories and revolutionized thinking about the canyon's history. The evidence Young had uncovered was the alignment of pebbles in the bed of the river.
If you look at these pebbles, you can see that the pebbles are flowing, or the pebbles are oriented in this direction, which is a stable direction for water flowing to my right. If the pebbles had been oriented this way, the water would have flipped them over. So when we find pebbles that are oriented this way, that tells us that the water was flowing to my right.
It is a crucial clue. The Colorado River could never have flowed to Young's right. It has always run in the opposite direction, towards the Pacific Ocean. The river here, 50 million years ago, was not the Colorado, and it did not cut the Grand Canyon. Young's findings meant scientists had to rethink all their ideas about when the Colorado had arrived on the plateau and about the age of the canyon. They started examining evidence from another, less ancient site. This is Muddy Creek, near Lake Mead, Arizona, just a few miles downstream from where the Colorado River exits the Grand Canyon today. The underlying rocks prove that this was once the site of a vast freshwater lake.
The upper part of the Muddy Creek Formation is this nice limestone which formed in a freshwater lake. The water would have been very clean. There would have been lots of plants and animals living in the water, and as they sank to the bottom, the calcium carbonate in their shells would form this limestone, which is typically what forms a limestone rock.
The limestone is the calcified remains of the creatures that once lived in this lake. Then, 5.5 million years ago, the animals all disappeared. There were no shells to make fresh limestone. The only explanation is that the animals died 5.5 million years ago because that was the date when the Colorado River arrived here. The river would have been carrying masses of dirt and rock sediment from the fledgling Grand Canyon.
The water would have been too muddy and dirty, and limestone does not form in dirty, silty, muddy water. It's just incompatible in such a lake. Can't exist if there's a lot of silt and mud in the water.
So, the muddy death of the lake gave geologists a confirmed date for when the Colorado arrived in Arizona and commenced its excavations. The Grand Canyon was born a mere 5.5 million years ago. The investigation has reached a significant milestone. It has discovered the age of the canyon. The angles at which pebbles lie in ancient riverbeds reveal that the Grand Canyon is far younger than geologists had previously ever suspected. The limestone discovered at Muddy Creek reveals the date that the Colorado River arrived on the plateau and the true age of the canyon, 5.5 million years old. Now geologists had a new mystery to solve, discovering why the Colorado River took the path it did some 5.5 million years ago, and why it carved a canyon of such remarkable dimensions. The investigation into the history of the Grand Canyon has uncovered a 1.7 billion year old landscape that has evolved from ancient mountains through to the Colorado Plateau. 5.5 years ago, the Colorado River began carving out the Grand Canyon from this plateau. The question scientists now had to answer was what happened at that time to cause the river to dig deep and carve out the canyon. It is a debate that has been going on for more than a century and which continues today.
I got interested in the Grand Canyon when I went to school and started studying, and I heard about the different ideas associated with the Grand Canyon and was just blown away when I found out we did not understand how the Grand Canyon formed. Something as iconic as the Grand Canyon wasn't understood, just seemed crazy to me, and so basically decided to dedicate a large portion of my life to trying to figure it out.
One theory is that several ancient rivers merged and their combined cutting power started digging out the canyon. Another assumes that years ago, the Colorado River began carving out the Grand Canyon from this plateau. The question scientists now had to answer was what happened at that time to cause the river to dig deep and carve out the canyon. It is a debate that has been going on for more than a century and which continues today.
I got interested in the Grand Canyon when I went to school and started studying, and I heard about the different ideas associated with the Grand Canyon and was just blown away when I found out we did not understand how the Grand Canyon formed. Something as iconic as the Grand Canyon wasn't understood, just seemed crazy to me, and so basically decided to dedicate a large portion of my life to trying to figure it out.
One theory is that several ancient rivers merged and their combined cutting power started digging out the canyon. Another assumes that the river cut down into the plateau as the land uplifted around it. But John Douglas has his own theory, one that has gained respect among many leading geologists since he first published his ideas in 2000. What Douglas calls his spillover theory seems to work well on paper.
Spillover is incredibly easy. All it means is the Colorado River poured into a basin. When it poured into that basin, it had to form a lake. And this lake was huge. All that lake had to do was rise and then spill across the plateau. It poured down, cutting rapidly, and over time you would have ended up with the beginnings of Grand Canyon very quickly.
At his college campus in Phoenix, Douglas is building a scale model experiment to see if his spillover theory actually works in real life. He sculpts tons of dirt into a model of the Colorado Plateau. Running faucets represent the flow of the Colorado River into the ancient lake.
Now we have our large lake. The water's getting higher, it's getting ready to spill across. We have a tiny little trickle of water pouring down off the lake. That little tiny trickle of water doesn't seem like much, but over time, that little bit of water flowing down that steep slope is going to gain energy, it's going to start cutting, making waterfalls that work their way back. One waterfall has now reached the lake. You can see that we have just released a significant amount pouring down. Now we have huge canyon cutting. Landslides are sloughing off the side of the canyon walls, the water flushing it downstream. The lake, you can see that it's starting to shrink in size. That lake is getting lower. And right there, you can see that we've cut our own small-scale version of the Grand Canyon.
Douglas's experiment proves that the spillover theory works in miniature. But he needs evidence to show that it could have happened on an infinitely bigger scale. Douglas sets out in search of a lake, large enough and old enough to be the source of his spillover flood. He has a prime suspect in mind. This is the site of the ancient Lake Bittahoche, 100 miles to the east of the Grand Canyon. And a clue here on the old lake bed reveals how deep this lake once was.
These green clays, which indicate deep lake water, this is the classic evidence for the giant lake necessary for the overflow explanation of Grand Canyon.
These green deposits are only created in one specific.
To have green lake clays, you need deeper water where there is little oxidation. I think that's indication that the Colorado River has arrived in this basin, that it's made its way from the Rocky Mountains to this location. And this is its basically stopover point before it eventually spills across to form the Grand Canyon.
Establishing the depth at this point lets Douglas work out how large an area was once covered by water. He compares the depth of the water with the contour height lines of the surrounding countryside. And that shows that Lake Bittahoche once spread over 20,000 square miles and contained more than 3,000 cubic miles of water. That makes it bigger than Lake Michigan. Douglas needs to date the age of this lake. For his spillover theory to work, it has to be older than the Grand Canyon, more than 5.5 million years. He unearths the proof he needs in these deep water fossils.
Okay, these fossil shells are freshwater mollusks, maybe as young as 6 million years old.
The dates match up. The lake was here at the right time to have spilled over and begun cutting the Grand Canyon. Helped confirm Douglas's belief, but his search for more evidence continues.
In reality, we're never going to know how it formed to 100% certainty unless someone builds a time machine. By doing this kind of work, all you're trying to do is increase your level of confidence on your ideas, build up your case, build up your evidence.
Building up his evidence is exactly what Joel Pedersen is doing. He is using the very latest technology to prove exactly how fast the Grand Canyon was carved. He has found the evidence he needs right here, at the very start of the Grand Canyon.
Here at Lee's Ferry, there are all of these gravels that are evidence of where the river has been in the past and the path that is taken during incision. And amongst the gravels, sometimes you see these great lenses of sand, and we can use the sand to get an absolute date on these deposits.
As the Colorado River carved out the canyon, it deposited more and more of the gravel and sand debris at this spot. Newer layers buried older layers over millions of years. And geologists now have instruments that can measure how light has affected individual. That reveals precisely when each sand layer was originally buried, away from the light of the sun. For the technique to be accurate, it's essential that the sample is not exposed to daylight.
So here we can take a metal tube and we can hammer it into the sand outcrop, and in the metal tube then we'll get a sample of the sand and it'll stay out of sunlight, and then we take it back to a darkroom laboratory and remove the sand still sheltered from light, and then we can analyze the optical properties of it to get an absolute age. And in this case, the absolute age would tell us when the river was at this point in the landscape.
Back at the lab, Pedersen compares multiple sand samples, each from a different depth in the canyon deposits. Discovering the age of each individual layer of sand lets him estimate how rapidly the river has been cutting down through the rocks.
Here at Lee's Ferry, we can use this last 500,000 year history along with our absolute dates and all the information we get. And the rate of canyon cutting here is about 1,000 feet per million years.
That's 1 foot in a little more than 1 inch every century. It proves that the entire 5,300-foot deep Grand Canyon could have been cut in a little more than 5 million years. In geological terms, the mere blink of an eye. The investigation is assembling evidence on how the Grand Canyon was created. Green clay deposits support the theory that an ancient lake was big enough to spill over and trigger the canyon's creation. Deep water fossils prove that the lake existed 6 million years ago, the right time to have overflowed and cut the Grand Canyon. But proving how the canyon cutting began is only part of the investigation. This is one of the widest and deepest canyons in the entire world. And to discover how it grew so large, geologists will have to examine some of the most dramatic and dangerous features the canyon has to offer. The landscape of western Arizona has transformed from ancient mountains to prehistoric seas to a flat, uplifted plain. Just 5.5 million years ago, the Grand Canyon was cut through this plateau. It happened so fast that geologists had to think again about the awesome power.
It cuts through rock not by the water wearing it away. You could pour water over rock for a long time and nothing would happen. It's the tools that the river carries. The river carries boulders and sand, and those bump against each other and they eat away at the rock.
Every day, the Colorado can carry almost 500,000 tons of rock and debris, enough material to fill more than 100 Olympic swimming pools. That is 5 tons every second. So investigating river erosion is never an easy task, because the powerful flow of the Colorado River has scoured and washed away many of the clues that the rock detectives need. They looked for evidence in the hundreds of rapids that disrupt the river's progress. The swirling rapids are created when flash floods sweep boulders into the river from the many smaller side canyons.
The river has to focus a lot of energy at these points to deal with all of the boulders that are coming in. The more coarse boulders and more resistant material that the river has to fight against to accomplish its incision, the steeper it gets.
As the water flows over the rapids, it cuts deep into the bedrock below. At this set of rapids alone, the river drops 10 feet. And there are a lot of rapids on this section of the Colorado.
So it put all these rapids together in a string through Grand Canyon, and that gives you the overall sort of unusually steep Grand Canyon profile of the river going through it.
Gravity and simple physics are at the heart of how the Colorado has carved so much rock so quickly. 5.5 million years ago, the Colorado River was flowing over the steep edge of the plateau that had been pushed up thousands of feet above sea level. The river ran rapidly over the steep downward slope and swept rough, rocky debris along in its wake. An incision formed, digging back into the edge of the plateau.
The power of the river to incise as it dropped off that huge escarpment must have been really great. And so the river quickly incised there, and that very steep drop-off of incision would have worked its way back upstream through the Grand Canyon region. It's that a few million years later has spread itself out through the length of the river.
It is this steep drop-off between the Colorado Plateau and the land beneath it that fuels the Colorado's incredible erosive power. The river begins its life high in the Rocky Mountains in Colorado. For every mile that it travels, the river falls 10 feet. By contrast, the Mississippi River, a river moving 10 times as much water as the Colorado, meanders across a flat landscape. With no steep slope to drive it, the Mississippi can't carve any canyon. But the Grand Canyon is not just steep, it's also wide. And here, on the south rim, at the heart of the national park, the true majesty of the Grand Canyon is revealed. This is where the canyon is at its widest, as much as 18 miles from rim to rim. This landscape appears serene now, but its unique beauty was forged by violent forces.
Oftentimes, we just associate it with the Colorado River. The Colorado River is what cut the Grand Canyon. It formed the initial gash to allow the river to flow across. But what makes Grand Canyon grand is really its width. and all the layers of rock that are exposed. And that isn't only solely tied to the Colorado River. What's happening is this rock that's exposed, it's being beaten on by rain, and the rain gets in there and it weathers the rock and it weakens it. And then because this is so incredibly steep, gravity will act on that material, transporting it deeper down into the river, flushing it back out. And that process just repeats over and over again to allow the canyon to get wider over time. We have classic rock falls that are cascading down onto the black rock in the far distance. Those events are indications that this is actively ongoing canyon widening and retreating from these processes.
The fall of these rocks is not a gradual process. This is erosion at its most violent.
Very few people are ever going to see Grand Canyon actually change. Like, I've spent numerous nights in Grand Canyon, I've only heard 1 or 2 rocks ever fall. But change will happen, and when it does happen, it happens very rapidly.
The rocks fall because both harder and softer rocks are layered, one on top of the other, in the canyon walls. The harder layers are made of limestone and sandstone. These rocks don't weather easily. The softer shale beneath is made of mud that expands when it rains, causing the shale to crumble away.
Those weaker rocks, they weather and retreat back, and they undermine the resistant cliff rocks above that will then fail as dramatic rockfall landslide events, allowing the canyon to increase its width.
The rock falls are merely the first step towards increasing the Grand Canyon's enormous width. Without the help of an accomplice, the entire canyon would fill up with debris.
Without the Colorado River, you could not have the Grand Canyon as wide as it is. By flushing that material downstream, it wipes it all clean to allow a whole new material to build up again. And once you repeat that over and over again, it allows the canyon walls to retreat back. And the entire canyon just grows. These guys continue to march and push and move all that material downstream.
The mystery of how the Grand Canyon grew so deep and so wide is being solved. The Colorado Rapids demonstrate how the steepness of the riverbed helps carve the canyon so quickly. Rock falls on the canyon walls reveal how weaker rocks rapidly widen the canyon across the plains of Arizona. But this is far from the end of the Grand Canyon. In just the last million years, the canyon has been transformed by other overwhelmingly powerful natural forces. Geologists have established that over 1.7 billion years, the Grand Canyon emerged from ancient mountains and prehistoric seas to become one of North America's geological icons. This is a rare look at one of the most remote and secret parts of the Grand Canyon. A series of small cone-shaped mountains line the canyon's edge. And there are flows of black rock running down from each rim. They come from a remarkable era just 725,000 years ago, when the peace of the canyon was shattered by volcanoes. This is Toroweap Point, in a remote area known as the Arizona Strip, one of the most isolated places in the continental U.S. Few people other than geologists ever see this area, although it boasts some of the canyon's most stunning views. The rock detectives come to see how explosive volcanic eruptions have changed the canyon in the comparatively recent geological past. This black rock that seems to have spilled over the rim of the canyon is an ancient lava flow. What was once boiling hot rock, forever frozen in time.
Powell talked about a river of molten magma pouring down into a river of melted snow. And he talked about how dramatic it must have been, the boiling and seething and the steam, and it must have been amazing. You would picture red hot lava like you would see in Hawaii pouring down the canyon walls and coating them. And then once it reached the river, it would immediately create just giant clouds of steam.
The extensive lava flows, erupting from as many as 100 cinder cone volcanoes, had a dramatic effect on the Colorado River running below. Crow believes that on at least 8 occasions created huge lava dams that blocked the river completely.
Well, behind me here is one of many basalt remnants. They're the remains of lava flows that poured down the canyon, partially filling it. And then subsequently, the Colorado River has removed all but a few little chunks.
The lava dams brought even the powerful Colorado River to a halt. For a while. In time, the dams were no match for the Colorado. The rising pressure of the dammed river behind them, and they shattered. This explosive episode has left its mark on the canyon's walls. Today, the cones appear to be extinct and lifeless, although some geologists believe that the volcanoes might not be finished quite yet.
The last eruption that sent lava pouring into Grand Canyon probably occurred about 100,000 years ago. There is evidence for an eruption on the rim that didn't actually make it into Grand Canyon that's 1,000 years old. So there's I think a good chance there may be eruptions here as well.
The Grand Canyon's future has yet to be written, but investigators now understand the story of its past. The calcium in the garnet discovered at the base of the canyon reveals the ancient beginnings of this landscape, an immense mountain range. Limestone rocks show that the canyon was only formed 5.5 million years ago. Green clays that can only form in deep water prove that a huge lake, bigger than Lake Michigan, could have been the trigger for this canyon carving. And rock falls from the crumbling cliff faces of the canyon rim are evidence of how the canyon grew to the shape it is today. Geologists have been studying the canyon since the mid-1800s. Yet even after more than a century of investigation, the story is still far from finished.
The landscape is evolving and it's going to be changing through the geological future. And so the story about the geology and the fascinating questions here is not one that's over, and it's going to continue to evolve as scientists continue to do work here.